This video is on solving absolute value inequalities. Alright, so let's talk about absolute value and when it comes to inequalities. So let's say I have two scenarios. I can say, hey, the absolute value of x is less than 7. The absolute value of x is greater than 7. We can do less than or equal to, greater than or equal to, but let's just talk about less than and greater than because the rules are going to be pretty similar. Alright, absolute value of a number, I want less than 7. So let's think about this on a number line. We have the number 0. And if you remember, absolute value is how far you are from 0, your distance from 0. So if I want a distance less than 7, I can't go past -7 and I can't go past 7. It has to be between 7 and -7. So somewhere in between. And what does that look like to you? You know what that looks like to me? That looks like an and. That looks like an and absolute value, an and compound inequality. So somewhere between -7 and 7. So we're going to think less than and even better, less, double inequality, and it'll make our life so much easier. Okay, so double S, double inequality, less than and. For an or, so I gave it away. For a greater, I was writing in white. Okay, so if we want the absolute value to be greater than 7, so here's 0, here's 7, here's -7. So if we want to be greater than 7, we want it to be any number bigger than 7. All these numbers have an absolute value greater than 7. So do these. Like -20, its absolute value is 20. That's greater than 7. So what does that look like? A greater than. All right, so -infinity to -7, union 7 to infinity. That is an or. So the way I think of it is great or, which I know that's not how you spell greater, but great or than. So when it comes to absolute value inequalities, if you're given a less than, we're going to think double S, double inequality. For a great or than, we're going to think great or, and we're going to write it as an or. So there's those rules. So start by, this is the way we're going to solve. We're going to start by isolating the absolute value on one side of the inequality symbol, just like an equation. So solving an absolute value inequality problem is really similar to solving an absolute value equation. We're going to still start by isolating the absolute value on one side of the symbol. Then we're going to follow these rules below. If it's less than, we're going to write it as a double inequality. If it's greater than or equal to, so I should have said less than or equal to, we're going to write it as a double inequality. If it's greater than or equal to, we're going to write it as an or. So let's do a couple examples, maybe more than a couple, probably about 4. So let's do x plus 4. The absolute value of x plus 4 is less than or equal to 9. And then let's do the same expression. So absolute value of x plus 4, but then we'll solve it as greater than or equal to 9. All right, so number 1 is less than. Less than double S, double inequality, or less than and. So we're going to write x plus 4 less than 9. Ooh, and it's got to be greater than or equal to -9. So notice on the left-hand side, all I did was take that 9 and make it negative over here. So notice that in the rule. Okay, positive on the right, negative on the left. I'm going to solve this. Remember, whatever I do to the middle, I have to do to both sides. Okay, and I get negative 13 less than or equal to x less than or equal to 5. All right, so, and then again, because we're looking for when it talks about less than, we need it in a space. So I don't want my distance to be too far. So it gives it some sort of space to be in, so a confined space. So my solution is negative 13 to 5. And you can also graph it. Graph it. So here's negative 13. 5 would be here. Brackets because it's or equal to, and it's all those numbers in between. When I substitute it in, will give me an absolute value less than or equal to 9. So if I chose 0, which is in between those numbers, I would get 4, which is the absolute value that is less than or equal to 9. So, less than, double inequality, positive on the right, negative on the left. Notice my inequalities point in the same direction, okay, because x plus 4 is greater than negative 9, but it's got to be less than 9. All right, so now let's look at example 2. That is or, because it's great or than. So I'm going to say x plus 4 greater than 9, or x plus 4 less than, okay, notice that sign switches because now we're talking about the negative 9. Okay, just like in the double inequality, which this expression is greater than, so x plus 4 is greater than negative 9, we have to switch this guy. So that's the most important step. Notice that switches. Okay? Notice that switch. So I'm going to subtract 4. X is greater than or equal to 5. Subtract 4. X is less than or equal to negative 13. I have to look at a graph of an or to write it. So, negative 13, 5, brackets, because it's or equal to this way. So let's write that. Negative infinity, negative 13, bracket, that union, so that means or, 5, comma, infinity. All right, so any numbers in that space will give me a true statement. So let's say I choose negative 15. Okay, negative 15 is over here somewhere. Negative 15 plus 4 is negative 11. The absolute value of that is 11, which is bigger than 9. All right, so less than, double S, double inequality. Great or than, written as an or. Let's do a couple more examples. So we're going to do number 3, 5x plus 2 minus 3. So absolute value of that greater than 10. And then example 4, the absolute value of x minus 7 over 3 is less than 7. All right. Before you can pick if it's greater than or less than, you need to isolate the absolute value. Because don't forget, if I divide it by a negative, that's it ultimately switch my inequality. All right, so let's look at example 3. Let's get the absolute value by itself. Minus 3, I would add that 3 to both sides. So get absolute value of 5x plus 2 is greater than 13. That's an or, great or than. So I'm going to split this into 2. 5x plus 2 is greater than 13, or 5x plus 2 is less than negative 13. Now I solve the two inequalities. I'm going to subtract 2 and divide by 5. Subtract 2. 5x 11, whoops, greater than 11. Divide by 5. X is greater than 11 over 5, which is 2 point something. Subtract 2. 5x is less than negative 15. Divide by 5. X is greater than, whoops, x is less than negative 3. Again, for ors, got to put them on a number line. So -3, and then 11.5 is 2 point something. So let's see. It's greater than 2 point something, but it's less than 3. All right, so let's write that in the interval notation. Negative infinity, -3, union, 11/5 to positive infinity. So all those numbers give me a true statement in that inequality. All right, so let's look at number 4. The absolute value is by itself. It's a less than, double S, double inequality, less than 7, greater than -7. To solve this inequality, remember you do what you do in the middle, you got to do all 3. So I'm going to multiply by 3 to get rid of that 3. So I get -21. These 3 cancel. X minus 7. Which is less than positive 21. Now I'm going to add 7 to all sections. So let's see. 21 plus 7 is 28. X less than -21 plus 7 is negative 14. All right. So let's graph that. -14, 28, all the numbers in between, parentheses because there's no or equal to, and then that's it in interval notation. So absolute value less than, double S, double inequality. Absolute value greater than, think great or, and that would be an or.